Hello. Tonight we have slope part 3. This video deals with the application of slope. So here we have a graph. Notice that this graph is charting tomato plant growth. And the y-axis represents the height of the plant in centimeters. And then the x-axis represents time in days. So here we have a linear, a linear equation. We don't have the equation, but we can figure out the slope from the graph. All right, so to do that, we would pick any point on the graph, and then we can count the rise, and we can count the run, and that would give us the slope of the line. All right, so let's say that we started at day 1. All right, at day 1, the height of the plant is between 0 and 5, and these are even increments. So what number is exactly between 0 and 5? Well, if you said 2.5 or 2.5, you'd be correct. So it looks like on day 1, the height is 2.5, and then on day 2, the height is 5 exactly. So the change, or the rise, the vertical change would be 2.5 centimeters. And the horizontal change from 1 to 2 is 1. Okay, so here we have the slope of the line. The slope is 2.5, and it represents 2.5 centimeters of plant growth per day. And it works because if, let's say that I went from day 2, which is the height of 5 centimeters, if I go to day 4, up here, then the plant grew 5 centimeters, and it took 2 days to grow it. So 5 over 2 is the same as 2.5 over 1. So again, it's the same ratio. And so our rate of change, our growth, is 2.5 centimeters per day. All right, here we have a graph which is graphing the temperature of heated water. And the vertical axis represents water temperature in degrees Celsius, and the horizontal axis represents time again, this time in minutes. All right, so again we have a line. So the slope of this line should be the same between any 2 points. All right, so I can start anywhere. How about if I start right here? I'm going to start right there because I know for sure that that point is on 60 degrees, right there. Okay, and this is going to be the temperature after 1 minute. Okay, so now I'm going to choose to go up to this point because again I know exactly what the temperature is there. It's 80. It's right on the line. Here I'm guessing it's probably 70, but I don't know for sure, so I'm better off using the numbers I know for sure. So I do know that the temperature, the rise, went up by 20 degrees . Okay, it went up by 20 degrees, and the run was 2 days. Or 2 minutes, excuse me, 2 minutes. So my slope should be 20 degrees every 2 minutes, and I can reduce that ratio to 10 degrees per 1 minute, or 10 degrees per minute. And that does make sense. So this point would be 70. This point here would be 90. And the initial starting point right there would be 50. And I didn't use it because, again, I wasn't sure exactly if that was 50 or not. I thought it was, but I wanted to use the points I did know for sure. All right, so my slope represents then the change in the temperature of the water every minute. It's plus 10 degrees. All right, here we have a graph on gasoline usage. Our horizontal axis is the miles driven, and our vertical axis is the number of gallons that is in the tank. So 0 miles driven would be right here. And that's when we have a full tank. So this car or vehicle will hold 15 gallons of gas. All right? And so as we travel, the gas tank is going down. This is going to be a negative slope. And we want to calculate the consumption of the gas. So let's see, we can pick any points you want. How about right here? Okay, the gas went down by 1 gallon after the car or vehicle had traveled 25 miles. So my slope of this line is negative 1/25. Okay, it's going to go down 1 over 25. Down 1 over 25. So that tells me then that this vehicle uses 25 miles per gallon. Okay, that's what that tells me, because I'm using up 1 gallon for every 25 miles. All right, let's try another one. Okay, here we have a graph. It doesn't have a title, but it does have a vertical axis that has to do with volume in liters. Okay, so this is probably liquid or some kind of water or some kind of liquid. And then my x-axis is time in minutes. All right, so it looks like the volume is increasing. So maybe this represents a tank of some kind that's being filled with water. And this is the rate at which it's being filled. And it even has an initial amount that's in the tank. Okay, it looks like that would be 200 liters. Okay, so maybe that was right down here. Okay, it had 200 liters in the tank, and then water is pouring into this tank, and it's filling up at a rate. Okay, so let's calculate what that rate would be. So let's see. After 2 minutes, we have 400 liters. Okay, so the rise, if I start at 0 and go to 2, the rise in the number of liters would be 200, because I went from 200 to 400. And the run, the horizontal change, is 2 minutes. So it looks like 200 liters in 2 minutes, and I can reduce that to 100 liters in 1 minute, or 100 liters per minute. Okay, and I think that's going to work, because it shows that every two minutes it increases by 200. So yes, that would be a rate of 100 liters per minute. So this represents then, the slope represents how fast the volume of this tank is being filled. All right? Okay, so that will do it for tonight's video. Thank you for listening, and I hope you find this handy when we do our problems in class. And remember, read some books.